Hello everyone, welcome back to my YouTube channel. Or if you're new here, welcome. I'm very glad that you're tuning in today. So a little bit of a live update on my end that I would like to share with you, and that is that due to a workforce reduction in my company, I was recently laid off from my role as a data analyst slash econometrics specialist as of late April, early May 2025. Yeah, it's been a difficult transition for me so far, but I'm staying positive and I'm using this time to grow, learn, and hopefully help others along the way. So, since the layoff, I've been actively applying for new roles, and I'm excited that one of the companies I applied for got back to me a few days ago with a request. They shared a data set with me and with the specifications about what they want this project to entail, and they asked me to specifically asked me to use Power BI in producing the output. So while I was brainstorming about the project and how to approach it, I thought, why not bring you all along for the ride? This way I can get to work on a project and also share some practical hands-on Power BI knowledge with you. So, of course, I want to respect the confidentiality and data privacy of this company. So I've replaced all of the sensitive and proprietary information in the data set with my own dummy data. That means that the structure and logic will be real, but the content itself is entirely fictional, just to keep things ethical and professional. So if you're someone trying to get better at Power BI, or you're just curious to see how I approach data, storytelling, and dashboard design, which this project will more lean more toward getting that output they asked me to provide them. But still, if you're interested in improving your Power BI skills end to end data from data manipulation in Power Query to storytelling in Power BI Desktop. Please stick around, and together we're going to dive into this project. So let's do it. And here we start. What you see on the screen is the email that was provided to me by this potential employer, which I copied and pasted into this Microsoft Word sheet. And as you can see, there are 3 steps in the application process that I need to complete, where I completed the screening part of it, and I have to complete 2 more, one being the current simulated project, which I'll work on today. And lastly, if I do well in the simulated project, I'll be taking an interview with them. So what else? They have a series of instructions that they would like me to follow. They specify that this is a simulated consult, not a real business case. So although it's not a real data, but they simulated it to look like a real world business problem. And what they're really trying to do is see how I approach the solution from a problem solving and critical thinking perspective. So I blacked out their information for privacy and compliance standards. Ask questions. If I have any question, I can email them. I don't see any problem to reach out back to them, so we should be good to go. Third, they want me to perform this project in Power BI, and they give me kind of a discouraging statement here to say that only 95% of candidates 5% of candidates pass it, so there's a 95% failure rate here. So you're saying they're not looking at if I'm good, they're looking at if I'm obscenely good, right? So I it should be easy based on the Excel data sheet that they provided me. I don't see any major problem, but we will see. And they're really looking at my DAX, which is the data analysis expressions, in other words, the calculations that I write while creating the measures. And then have fun.
added bonus. They found that this has actually improved people's skills along the way. Well, that's good. That's encouraging. So I want to be able. I'm always looking to having opportunities to improve my skills, and along the way, I want to share that knowledge with others. So, and with all of that being said, once again, they're really looking at the screenshot a legacy report from the Excel file. So it's time for me to go and open their data set, which is this Excel sheet they provided me. The first tab is this legacy output. In other words, they want me to replicate this report in this project. So looks like there's 4 columns here. Month when customers made first purchase, customers, percentage of customers who return within 90 days of first purchase, and percentage of customers return within the following 3 months. And then 3 more tabs, one for sales, one for product categories, and one for customers. So in other words, they're looking at a segmentation of month and year, and how many customers made first time purchase in those months and years, those months of the years, and then how many of those customers that made the first purchase return within 90 days, and how many of them return within the following 3 months. And they're really not looking at like how many, meaning quantifying the number of customers. Instead, they want to measure it using percentage proportion here. So should be easy by connecting or by relating the unique keys from the customer key versus the unique keys in customer key in the sales table, between customers and sales table. I don't see a use for the product categories, but I'll just leave it there for right now. Let's go back to the instructions. So they're asking that I should recreate that legacy report which I just showed, and they want to evaluate my understanding of the tax language and my data modeling in Power BI. And they said in the future, if I get hired, the client will ask me to add additional data to analyze along the sales data, and will desire time intelligence calculations. Not a problem. And then lastly, impress them by designing an additional 1 to 2 pages of report demo, highlighting your capabilities in terms of both data analysis and report design. So just an attached demo report demo to highlight my approach and methods. And once again, they're saying that when you're done, please send your PBIX solution file, which is the Power BI file, to that email they provided me, and then the solution will be evaluated based on the following criteria. The first criteria is the data model quality, which is when I model the tables in Power BI. Transformations and calculations, how I transform the data and create calculations or measures. Report design, which is how I designed the report, which is really not a lot. It's only 1 table output, is what they're looking for. And then additional demo report, which is what we just reviewed up here, that they want a couple of pages of demo report based on what I have done. And the deadline for this final submission, they specify, is 3 weeks from receiving this communication. Okay. All right, so let's just go back to the data. This is the data sheet or an Excel data set where they have created these tables in formatted tables. So they're not CSVs, they're formatted established tables that I need to work with. And once again, I have customers table that has all the customers information, customer key, alternative customer key, first name, last name, birthday, marital status, gender, yearly income, total children, English education, English occupation, house owner, flag, number of cars owned, address, date of first purchase, and then commute distance. So based off of that report for application, I don't think I will need to use all of these columns except for a few, maybe like date of first purchase and the customer key. And if I have to add any additional granulation breakdown of customers by gender, marital status, or birthday, that kind of stuff, then I may use the other columns or variables. But for this particular output, I don't need all the other columns. Definitely they don't need this table. Doesn't really serve any purpose. And then the sales data set, which is we have the product key. That's something that probably can talk to the product category, right? So there's a product category here. There's no product key here as well. So don't see how I can use this. Should have a customer key. There you go, customer keys here. Order date, customer key, sales territory, sales order number, line number, order quantity, discount amount, product standard cost, sales amount, territory region, territory country, territory continent. All right, so what did I do? So as you can see in here, they specified that this is going to be a simulated consult. So I wanted to avoid any privacy or compliance violations. So I pretty much recreated the data. So their data was, and the customers were in thousands, and the sales were in like almost 40,000 of sales records. The customers was like around maybe couple thousand. So I removed their data, and what I did is I recreated the data simulation to just replace them with these, just to be able to work on this project and record it for you guys. And then once it's done, I can just replace the actual data that the company provided me with these simulated data. And how did I do that? I used the Python scripting. I used 3 essential Python modules and libraries to generate realistic looking sample data that mimics the real business scenario as the one that was provided to me, but also to make sure that we are protecting sensitive information. For that reason, I had to recreate fake data here. So I used a random module, and random module introduces variability to the data, so that's very helpful. Pandas, this is a very important library in Python that's used for data manipulation, such as structuring, cleaning, exporting data, that kind of stuff. Then I use the Faker module, which is a core module in Python that's used to generate fake data, but also realistic, in a way that could be used for business solutions like the one I just used now. So again, the whole idea is for me to be able to test, share, and demonstrate the solution without violating their privacy standards. So use these 3 modules and libraries, define them here, and then create a list, use a for loop to create these random and fake values, and then appended it, and then lastly create a data frame, and then exported it into Excel. And once I exported it to Excel, I went back and I replaced these data with it. And then I also had to manually recreate the sales data so that it can correspond to the customer's data. What I can do is I can share this data set with this tutorial so that you can replicate it too. All right, and lastly, let's just go down the bottom of the sheet. I also created these key measures. So anytime you receive a task from that involves analysis, so it's always good to put together a business requirement document or technical specification document, however you want to, or whatever method or whatever type of document you want to put together based on the project. That's always good to document those requirements and write the objective and the goal and the use case of that project. So in this case, I pretty much wrote down this report for application output in terms of business key measures. So there are 6 measures or metrics that I'll be looking to develop this project. The first one is first purchase month, which the employer has labeled a month when customers made first purchase in this screenshot here, month when customers made first purchase. And it's segmented by month and year, so it's month and year. The second metric is the number of first-time customers, which is total customers with first purchase in each month of the year, and the company labeled as customers only, labeled customers. The third metric is customers who return within 90 days, which is count of distinct sales transaction customers made within 90 days of their first purchase. So this is not requested and this legacy output, but I just wanted to put it in there. The two metrics that are asked for are the percentages, but I wanted to also put the quantify those numbers and put them there as columns. Doesn't hurt, right? So what does this metric we look at? Once again, we're looking at customers who returned after they made the first purchase, who returned within the 90 days since their first purchase. So let's say if a customer made a purchase on January 1st, if they returned, let's say sometime before April 1st, then within that 90 days of window, if we assume that each month has 30 days, then those are the customers that will return within 90 days. And percentage is pretty much a measurement of the customers who returned versus the customers versus the first-time customers for that particular month and year, where the returnees within 90 days is the numerator and the customers number of first-time customers is going to be the denominator. All right, the next metric measure is customers who return within following 3 months, right? So again, it's not here, and looks like they used this is probably not accurate, right? So here it's all blank, so we assume that there's no customers return within the following 3 months. So once again, within following 3 months, I interpret that as customers who return within the window of 160, 90 days and 180 days. So let's say if a customer made a purchase on January 1st, then that customer returned within the following 3 months, meaning between 90 and 180 days of their first purchase. So that means they returned between April 1st and April, May, June. So July 1st, let's say, if we assume that each month is 30 days. And lastly, percentage return within following next 3 months, which they labeled it as PCT, or percentage return within following 3 months in the replication output here. It's pretty much a calculation of returned customers within the following 3 months in the numerator, and customers, first-time customers, in the denominator. All right, so this was the measures, more like a high level details of what the output would look like in terms of measures and calculations. All right, now that we are done with both introduction of the project and what the metric would look like, let's go to Power BI desktop. So let's just minimize this, and here we are. I already opened it. So Power BI is the tool that they requested I should use for the solution. However, there are a variety of BI tools like Tableau or Qlik, or even scripting tools like Python that can effectively solve this. But Power BI is what they asked for, and I think Power BI is a very powerful business analytic tool. As you may know, it's developed by Microsoft, and it's used very commonly for data visualization, but it's also used, but we can also use it for other advanced analytics, let's say data transformation and integrating scripting, or using DAX expressions or mQuery to perform advanced data exploration or data analysis. So Power BI is part of what they call Power ecosystem or Power platform, which also includes a bunch of applications like Power App, Power Automate, Power Virtual. So
what they do is they all work together to in synchrony to automate workflows, build custom application, analyze data, publish data onto the Power BI server, etc. So it's not, Power BI desktop is not one application, it's one of the application within the Power Platform ecosystem. Again, with Power BI, you can connect to hundreds of data sources from Excel to SQL to cloud platforms like Azure, Salesforce, Google Analytics, a lot, and you can use all of you can use Power Query, which is embedded as part of the Power BI, to transform raw data into kind of data that you can use to build interactive dashboards, insightful reports, create data table modeling, relationship, define business rules, and perform complex calculation using DAX or data analysis expressions. All right, so let's just get to the work. Let me not get too much details about the abstracts of Power BI, and get to the practice. So now that I'm in Power BI desktop, like I said, there are variety of connectors that you can use to connect to data sources, right? So let's start with the blank report. Excuse me. You can connect to these connectors using Get Data, or you can also do it from here, whichever you want. But if you click on More here on the drop down, you would see that all of the connectors here, as I said, you want SharePoint list, Active Directory. If you want to connect to on-premise databases, SQL Server, they're all here. So today what we will do is we're going to connect our simulated consulting project Excel worksheet, which in that case we'll just click on Excel workbook and click on connect, and it's right here, which I downloaded the other day. So double click on it and it should open the wizard for navigation. All right, so as you can see, it gives us a duplicate of these tabs. Not tabs, duplicate of the data, I should say. So you see the customers, product category, sales. These are the three formatted tables that we have, right? But it did not give us report for application as a formatted table. Why? Because report for application is not a formatted table; it's just a tab. So these the tables that appear here with kind of a black and white color scheme, these are the tabs. The ones that are here with like blue and white color scheme, these are the sheets, or these are the formatted table. So you can either use the tabs or the formatted table sheets to import them into your Power BI environment. So I will just use the tab for right now. Both of them should be the same, right? As you can see, if I click on customers, or if I click on customers here, right? Same thing. So I'll just go with customers. I'll just go with tabs, sorry. And I'll just select all my tabs that I need. As I said, I'm not going to need the report for application because it's just a screenshot. It's not a table. It's not data. That's why we don't have it listed as a data here. Once I do that, I have two options here. Either load it and go to Power Query, load it into Power BI desktop here, right? Which you see in the background, or transform it, which it will navigate me to Power Query. So again, we need to do some data transformation in Power Query before we bring our data into Power BI desktop environment. So I'll just click on Transform Data, and it should open the Power Query editor page for me. And here I am. So all of my three data sets or tables are now here. So Power Query is a very, very important like add-in, in this case for Power BI desktop. You can also use Power Query if you're using Excel, and if you want to edit or transform your data from Excel pivot and using Power Query, you can still do that. So it's more like a data editor that works for a lot of data analysis applications within Microsoft system. So in this case, we are going to do some minor data transformation and before we apply those transformations and load the data into Power BI Desktop for calculation. So what can we do, right? So let's start with a customers table. So I think a good practice is that to remove any columns or any fields that you don't need, because the more columns you have, the more data you have, the more it makes it difficult for Power BI to solve, especially if it gets if it receives a lot of complex modeling, and if you develop a lot of visualizations and calculations, then and if you publish it into Power BI service, then sometimes it can get slower because it has to deal with a lot of data. One of the ways that you can optimize it is to make sure that you don't use any unnecessary data fields. So that's one of the things I can see we can do right now. For example, for this particular project, we don't need the commute distance, right? So we can just right click on it and just say remove. And as you can see, as soon as I remove this column, I had a applied step added here, right? So this is a very important bar that appears here on the right that can record all of the applied steps as an archive here for you. And you can always go back and undo it, right? Like if I undo this remove column, I'll get that column back in here. There you go. So let's just remove it. I remove the commute distance, maybe number of cars owned, right? And this is not a big data set. I'm just doing this just to demonstrate, how you can do this. So maybe total children. So we just removed 3 columns from the customers table, and maybe we can. What else can we do? For example, yearly income, right? So if you click on it, this is a whole number, right? So if I go to source, navigation, change type. So if I look at the yearly income, which is yearly income, there you go. So it's an integer, right? Let's say sometimes when data entry is done, we have like dashes or commas, data errors that are caused by data input. So we just want to make sure that if we have a big data set of millions of records, then we want to make sure that we don't limit yearly income to just integer type, because if it's integer type and if you have an error in your integer data type added in among your numbers, then it will just cause all sorts of problem. It will just give you errors, and it's fair, right? So I'm always careful when it comes to integers or like specific numerical data, especially if I'm not sure what how data input is done. So in this case, we could just say type text, right, and change the integer to a text format, right? And you will see that this 1, 2, 3 is now going to change to ABC. That means it's a text format. And so we changed that. It's a transformation that we did. And you can do this for, let's say, like student IDs, if you're dealing with this table that has student information, or let's say any ID number, right? Which, although is fully numerical, but still it's a good practice to change it to a string or text, especially to avoid any data type, any issue that could be caused by data type. All right, let's go to product categories. We don't need to do anything there. And another transformation we can do here is data. See, column 1, column 2. That means that Power Query's algorithm could not establish the subcategory and category as column headers. So we need to do that manually. Otherwise, we'll have column 1 or column 2, and the headers or the titles of the columns are just appear as values here. So we need to transform that. Use first row as headers. That should solve it, I guess. There you go. So that's a transformation. As you can see, it added the applied step to the archives list here. And let's go to sales. Maybe in the sales we can just remove some extra. Maybe the continent. We don't need the continent. Bingo. Added the step there. Maybe we don't need the region. And maybe we need to change
Customer key, product key, order quantity. Maybe we can change the order quantity to maybe a string text. So where's order quantity? There you go. It's now a text. Okay, so again, in this project, I'm not aiming to teach you everything about Power BI, Power Query, but to walk you through how we can solve that simulated project. In the meantime, also explain what features I use within the Power BI. So I'm not going to get too much going to spend too much time talking about the minutiae of Power BI, but one thing I do want to make sure I go over is the merge query. So a merge query is pretty much like join, right? It's a different terminology used here. That means merge query here means joining tables. So Power Query has strong merging features that will allow you to join tables, merge tables, either append them or create a new table based on that. What makes it even more, first of all, as you can see, all of the join types that are pretty standard are all here, which you can just easily use using the drop down here. But what makes it more interesting is that it also allows you to do joins of tables based on matching criteria using the fuzzy. So fuzzy is an algorithm that I know there's at least a couple of modules in Python. For example, Fuzzy Wuzzy is something I've used before that you can use to perform advanced matching based on scores, matching scores, which apparently Power BI here calls it a similarity threshold. So what you do with the similarity threshold is that you assign a threshold going from 0 to 100, and based on that threshold, matching score, aka matching score, you can perform join between tables. Let's say if you want to join tables where the names match, but then the names between those two tables have typos, and let's say you have Michael spelled with CH, and then another table is spelled with a K. So the similarity threshold here, let's say at 80 or 85%, will be able to pick up those similarities and be able to join those tables, although there is a mismatch between the names of those two tables. So just wanted to kind of go over this, although we're not doing any joins, any table merging here today. Instead, we're going to do a relationship, which I'll talk about in the next step. All right, I don't see anything else to talk about or anything else to do actually. The data is ready. It's transformed and made ready for analysis. So what we do, we click on close and apply, and this will close the Power Query window and also apply all the changes that we brought here, and it will land us into Power BI Desktop, which is here. Should take a couple of seconds, should be quicker because we don't have a lot of data. And there you go. So all of our 3 tables are now loaded into Power BI Desktop environment and ready to go. We can test them by clicking on Table View here and click on each of the tables. As you can see, 30 rows for customers, which is what we have. 30 rows, right? 30 records. Product categories, and then sales is 20. I don't know about product categories, we don't use, so sales should be 20 and 20. All right, that means our data is ready to go. So first thing first, we need to look at our table modeling possibilities. So we click on the model view here, and as you can see, Power BI automatically created a model for us based on our table specification. So that tells us that Power BI is thinking that it's best if we use customer key in sales table and customer key in customers table to create a relationship between the two tables.
So let's just double click on this line and look at additional details. So Power BI also set a cardinality for us. So one-to-one cardinality means that all of the customer keys in sales table and customers table are unique. That means there's no repeated customer keys. That's why it's a one-to-one. So because this is not a real data, right? I said earlier that the real data that the company provided me has thousands of sales records, simulated sales record. So let's say for each customer, there's possibly it's designed to be for it to have thousands of sales, or I'm sorry, dozens of sales. Say a customer makes a first purchase in July, and then dozens of sales throughout the time. So that's why Power BI is telling us to that it's automatically established a one-to-one cardinality for us here. And the reason for that is what I just explained, that we don't have duplicate customer keys or in neither of the tables. In other words, all of the customer keys in both tables are unique, and that's because I rebuilt the data there. So that's not what we want, right? So we want the customers. We want the customers table will always have unique customer keys, but the sales table will not have unique customer keys. There will be duplicate customer keys. That because I just said there are multiple sales associated with a customer. So we want to click on many to one. So many sales and one being the table to customers. So it goes many to one. It goes from up to down. So if we click on, let's say, if we go back, let's say if we click on sales here and we click on customers here, now we have the customers. Oh, sorry. Customers here, and then we click on sales here. Oh, I wanted to see if I could switch them, but it's okay. So now it's one to many or many to one. That's what we need to do. Unless we can just remove this, right? And then reestablish a customer key onto the customer key. So let's see if we can get customers here and sales here. There you go. Now it's good. So now we can say one to many. Although we could also do many to one as well. So one to many. So there'll be unique customer keys here, and there'll be multiple customer keys and sales in here. So many, one to many. Click on make this relationship active, and maybe just keep it at single because we are querying from customer into the sales. That's called cross-filtering direction. That direction is single right now. And click on save. There you go. We just created a relationship between customer and sales. And I think it's better to just put it this way. So as you can see, because it's not a single cardinality anymore, in single cardinality you would see a one here and a one here. It's now one to many, so you see a one here and you have many here. So the asterisk means many, so it goes from one to many. So if I go back to my canvas here, if I were to get a table, and if I were to put all of the customer keys and the customers' names, right? If I go to sales table, if I get the customer keys as well, and order, let's see, what's the product? Do we have a product name here? Product key, maybe. You would see that based on that relationship that we have, we can create a table that has information combined from both tables. So we don't have to do any joins. In fact, table modeling based off the relationship between customer keys provided us with the ability to be able to create a table that has information from both tables where the customer keys between the two tables match. Just wanted to go over that really quickly, but that's not the aim of the work so far. All right, so what we can do here, we need to create a what we call date dimension. So I'm also not going to get into the minutia of
like modeling and schemas and snowflake and stars. There's when you model your tables, and there's several approaches to. So I'm not going to get into that, but instead at least make sure that you understand that uh, commonly there are several types of there are at least two types, dimension and fact tables, that I can think about on top of my head. Customers table in this case is a dimension table, sales is a fact table. So think about dimension versus fact table as where dimension has categories of what it is out there. In fact table is specification of what we have in the dimension table. So if the customer, and in customer table, the dimension has names of customers, but then sales table as a fact table has all of the information related to that customer. So think about dimension table as one and fact table as many. Let's say we're looking at a student table, right? Student table could be a dimension table, while GPA table, performance table, let's say exam score table, all of these could be fact tables that all go back to, represent those specific students from the student table. All right, so that is the fact table and dimension table for you. What we need to do is we need to create a dimension table for our dates. And that's very important, right? In this case, maybe we won't need a date dimension table because we already have dates here in both customers and sales table. But if we were to have multiple fact tables and multiple dimensions, right? There are complex data models where you have multiple fact tables and multiple facts. That's where the star modeling or snowflake modeling come into play. Then in that case, it's a good practice to have one table of dimensions of date dimension that will talk to the dates of all the other dimensions or of all the other fact tables. That is what we call a date dimension. And it's something that you don't have to really have for this, what we're doing today, but it's a good practice. If we were to advance this analysis into additional granulation, then you will definitely need to create a date table. So let's go to the tables here and create this date table. So the easiest way, there's several ways that you can start a expression, start a new table, but the easiest way will be to just click on table tools while you're in the table view here, and then click on new table, and it will open this status function sheet for you to write your DAX. So we're going to start by first declaring the name of the table. I'll just call it date table for right now, and then equal. So you specify the name of the table, and then just like Excel, think about it. It resembles, not fully, but in many ways, an Excel function. Right? An Excel function, you specify the name of the function, and then you put the equal sign, and then you write the function. So we're going to say add columns, which says create a new table, and then in this new table add the columns, right? And then you can say in this new column, give me a calendar, right? So I want to start with a calendar, and the first column should be let's say date, and the date should we have to specify a range, right? What this date, what range should this date cover? And say, let's say 2001. In fact, let's go here to our customers table here, and let's just sort ascendingly to look at all of the dates going from lowest to high. So February 2016 till February 2025, right? So we can put 2016, and then let's say put 2 and then 1. And then that's our first range, right? Then put the date for the second range, and then this time we're going to say 2025, and then maybe just put 3-1, okay? So we can cover February as well. All right, and then 2 parentheses, one for the add column and one for the calendar, and then put the comma. Now, if you do not want to write additional DAX for additional columns, you can just close it and we should be able to create the calendar, the date column. But that's not what we want to do. We want to have additional columns. So what other columns do we want to add? We want to add, let's say, year, right? So the name of the column will be, so when I say column, I mean a field, or a variable. There's so many terminologies used for it depending on the context. In this context, I'll just continue to refer to it as column. So that will be year, and then so I'll just declare year, and then in parentheses I'll just put the date, which is the one we just already declared up here, and close parentheses. And then let's just also have a month. I don't think I will have to use it, but I'm just going to do it. Add it. So format, and then so the format, and then the date, and the format we want it to be that will be the format for our month. And maybe lastly, we can just have a month, year, right? So that's important. That's something I'm going to be using. So that will be month and year, and format, date, then YY. Close the parentheses, and then one more closing for the add column. And press on this check mark or commit. And here you go. We just created 3,317 rows, which is a series of dates going from January. Let me just sort this ascendingly. Yep, going from February 1st, 2016, all the way till March 1st, 2025, right? Which represent this date here. In fact, let's do this. I don't know, why didn't I think about this earlier? Let's automate this so that let's say if we add data here, let's say if we add a date here, let's say April 1st, 2025, right? By that logic, our date dimension will not be able to pick up that date because we already specified it here manually. So let's just automate that. In other words, let's just pick it up from the date column from the customers tables. To do that, let's see, I think I'll have to use the calculate. I'll have to use the calculate, the context calculation is what I call. So minimum, and then the name of the table, which is the customers. So when you pass an argument that involves a column, then you first put the name of that table, then you pass the the column in the square bracket. So the date, was it called? For date first purchase. Okay, date first purchase. There you go. And then just close it, comma, and let's calculate, and this time just get the maximum for it. Date first purchase. Let's see if this will work or not. And it did. So if we were to, let's just check it actually if it works or not. Let's just put April 25, 2025, and just format it the way it is here. Okay, let's just put April 17, 2025. Let's see it. All right, let's go here. It's open, so I don't think it'll refresh. I'll have to close it, but let's look at the last value here, 2/16/2025. So let's refresh it and see it will capture that last value. All right, it gives me this error. This error is not saying anything about the table being open. It's actually telling me that for a one side of many to one relationship or columns that are used primary key, we do not have blank values. Oh, I see what it's asking, because we have blank values here. We can't have blank value when we're using a column as a primary key, so we can't. Yeah, so let's just give it a blank value here. So you can give it a value so you can avoid that problem. All right, and flip it refresh. Oh, I did not save it. And let's just click on refresh. Oh, this time it's asking me how to duplicate 1023. Oh, 1023 is already here, so let's just give it 1111. Who cares? Let's go. And let's just refresh it. There you go. So now let's go back to our date dimension table and let's look at the last value. And there you go. Our last value is 417. That's good. So I guess it worked out. So remember to use minimum max to capture date values that are continuously added instead of using one static range between two dates. So all right, happy it worked out. Let's go to the model view and do a couple things. So now we established the date table. We need to establish relationship between the date table and the dimension fact table. Maybe dimension table right now. All right, so my customers table does not have a column that represents the date of first purchase in a form of month and year. So let's just go and create a new column. Creating a new column, there are several ways you can do this. Either click on new column here, come into column tools once you're on the table view, or you can right click on any of the columns, or you can also do it through here by clicking on any of the tables and click on new column. So several ways to do this. Let's create a new column. So that we have done one thing so far. We've created a calculated table. Now I'm creating a calculated column. Later I will create calculated measures. So these are the three things you need to know. So the date dimension table, that's a calculated table, right? As you can see here, this is the symbol for it. And I'm creating a calculated column. Let's just call this column month year, and maybe month year customer. And let's just format the date of first purchase. Oh, remember, first we put the table name and then the name of the column, and then M1 month. That's standard I use for the other month and year and the date dimension. So click on commit here, and there you go. We just created a calculated column for month and year, parsed from the date first purchase column. Once I create the measure, then I'll talk about what the calculate table, calculate column, calculate measures would look like. All right, let's go back to the model view. Now we're ready to model our date table against our customers table. So the month and year is here, and the month and year is here. Let's just drag and drop this here. And automatically it selected many-to-many relationship, which makes sense because we have multiple values for each month and year, and we have multiple values for each month and year. Date table and for each month and table in the customers table. So this is good, and it's okay to have it both, and click on save. And there you go. Our relationship is now established between customers and date table. So far, I don't see the need for the product categories to include them as part of the model. Maybe we can use a category, find a category here, and then create a link, but it doesn't serve any purpose for this project. So just leave it as it is now. So let's just consider the modeling to be, it's very basic modeling to be complete now, and we're ready to, when you see these warnings, it doesn't really mean that you're doing anything wrong. It's just giving you a notice to make sure that you're aware that when you use many-to-many, that that means that
the model is looking at values that does not contain unique values. So you should expect a different behavior when you're using many-to-many relationships. So if you have unique values, then many-to-many is not recommended. So it's just a notice, just a reminder, nothing else. All right, so we are here. I guess we are ready to do. Remember, I was showing you earlier how I created a table and I put the values from both of the tables side by side, and you saw that how they came together. That's because of the relationship that we have in here in the model. So any measures that we create now, any work that we do now, as you know, when we drag and drop those values onto the canvas, you will see that it will automatically map each other based on the relationship that we have created. Right, so now that the relationship is built and the two tables can talk to each other based on the customer key in the customer table and based off of customer key in sales table, we're ready to create additional calculated columns and calculated measures. Let's start with calculated column. Let's go to sales table, which is where we are right now, and create another calculated column. And this time we're going to measure the date difference between the customer's first purchase and the customer's order date, right? Based on their unique customer keys. So let's just call this days since first purchase. So how long has it been since the first purchase took place? And we're going to use this function called date difference. And remember that anytime that you're writing a DAX that involves two tables that are in a relationship, they use related. And it helps you, extract and parse the related value from that table or the starting relationship in the backend. All right, so we're going to use related, and now we're going to use the customers table, which is the other table we're trying to relate to using the measures. Here we're going to specify the date of first purchase, and close the box. So first we specify that the relationship, or what the DAX should use as a relating key, and then we're going to specify the time difference. So the first time was the date of first purchase, and the second time will be from the sales table, and it will be order date. All right, once you put the order date, we declare the order date, then we can just lastly declare what type of difference are we looking at: hours, minutes, months, all of the categories or lists for us to select. So we just click on day. We're looking at the date, and we close it. And once you see that there's no underlines or any indication that the DAX has an error, and you're set to go, you can click on the commit button, and it should create the calculated column. And there we go. Our calculated column is created, and it's measuring the difference between days, the difference between first purchase date and order date of each customer. For example, let's look at customer, let's say 1001, right? Customer 1001 0. So that means he has 0 date difference. So what does that really say? Let's look at the customer data. So if we go to customer data, 1001, that's what it's saying, 1001. So his first date of purchase is March 2017. Okay. All right. So what about is March 7, 2017, and March 2017. So and order date is the same. So he made the first purchase, and this is his first purchase. So there's a zero date difference. That means he did not make another purchase. So this is not a customer record that we're going to include in our calculation because it's 0 date difference.
So this is the first purchase itself. It's not a subsequent churn or subsequent return of the customer. Let's look at another customer here. 30, and it's 1002. His order date is October 28, 2022. So keep that in mind. 1002, October 28. So 1002, September 28. So he made the first purchase in September 28. Okay, but we have a record for him where he made a subsequent purchase 1 month later, 30 days later, on October 28. So he is within that window of 90 days. So once again, this is the breakthrough for us to attain that difference, that time difference between customer one, but between each customer, between the two tables. And what really established this foundation for us to measure between the two tables is this model that we established based on the customer key. One thing I wanted to make sure I mentioned previously, I forgot about it, just remember now, is that when you do this exercise, you will see that there's an alternative customer key here that I did not check with the company. Either they wanted me to do a composite key sort of solution, or were they looking at the same a customer, kind of looking at both of these keys and comparing them against the sales, or were they asking me to use more like a single customer key and use this one? I didn't really check with that, so don't get confused if you see the alternative customer key. I did not use it at all, so keep that in mind. All right, so now that we were able to establish that, we can go ahead and proceed with with measures. We're going to write our first measure, and that measure will be under the sales table. So click on the sales table and right click either through new measure here from the table tools drop down, or from here click on new measures. Take you to the same place, but except that it's going to the function bar is going to show measure for you. So that's the standard name it gives you. You can delete it, and let's say we're going to say returned within 90 days. And so we're going to declare a couple of variables here, okay? We're going to declare a minimum days 90. That's going to be our first variable, and we're going to put 1 here. Next variable we're going to declare is going to be max days 90, and we're going to declare 90. So once we declare those two variables, we're going to return, which is pretty much, return is like when you, for example, declare a function in Python, and then you just use return to kind of execute it, right? So it's the same concept. Calculate, we're going to use the calculate function to contextualize this. And since we have the customer key from the sales, we're going to say distinct count. We don't want to count something twice, so we're going to use distinct count in sales and customer key. And then we're going to say distinct count of the customer keys where that was the first declaration, and then we're going to add a condition. So you're going to say where sales, and we're going to use that calculated column we created earlier, which is days since first purchase. So days since first purchase is equal to or above minimum days 90, which is this variable we just declared. We could also do it 1 here, but I think it's good to have variables declared here so that you can easily change it if any of these criteria change in the future. All right, so this is our first one, and then you see you don't have to put the the two you don't have to use the two ampersand here. When you use the filter in the calculation context, you will have to use that. But in this particular calculation, you don't have to use it. Instead, you can just use the comma, which means and here. So you're looking at and. So the logic is and. It's not and or. So we just declared our first condition where we said it should be above or equal to 1 day, which is this one, minimum days 90 to that minimum day. And then the next condition is going to be below or equal to, and then the second condition, which will be this one, maximum days 90. And so just close the parentheses and put the 0, and I'll explain why adding the 0 is important. And click on commit check mark here. So the measure is created. Something I said earlier I was going to do was to explain what the symbol or the icon or shape look like for calculated table, calculated columns, and calculated measures. So a calculated table is our date table dimension, which we created earlier, and the shape or the icon of the table is a table metrics and a calculator. That's so each time you see this, that means you're looking at a calculated table. And the calculated column is when you see a metrics sheet and a sum sign. That is a calculated column, and a calculated measure is the calculator. So anytime you see a calculator sign next to a created measure, then that is a calculated measure. So a calculated measure, if you go to, for example, you created it under the sales table. If you go to the sales table, a calculated measure does not have physical existence like the days since first purchase has, right? It's a calculated column. But the return within 90 days, this is a measure. So the measure does not have a physical existence. It only populates once you put it within the context of a table. And so it calculates once you apply it to the context of a table based on other variables or other dimensions. And you will see in a second here what I mean by that. So again, let's start by creating this output now. So our first, let's just create the drag and drop the table visualization here on the sheet on canvas here, and put the month and year. There you go. You have all the month and year and date segmentations broken down. Let's now put the return within 90 days, and there you go. That's it. It automatically populates for you once you apply it to a dimension for the table. Something that I have missed is to create this customers list or distinct customers list. So let's just quickly go and create that. Let's go to customers list and click on new measure. Remember, it's going to be a measure as well. Just call this customers list and just say distinct count of customers. So we're counting the customers by their unique keys, which is the customer key. So we want to make sure that we only count the customers once. So we don't want to count multiple customers. So unique count or distinct count helps us with that. And click on commit. So, and then click on your table here. As you can see, this table has 2 columns or 2 fields. Let's just add this third field, which is the customer list, and put it between the month and year, return within 90 days. And there you go. There you go. So broken down by month, year, customers list, return within 90 days. Very good. Very good. We're making progress here. Okay, let's create the the second measure, which is the return within the next 3 months, right? So again, either from here, drop down, or from the table, the data itself, you can click on new measure and start the new measure. So return next 3 months. We declare the name of the variable, and once again we're going to do the same thing we did for the 90 days. In fact, if you want, we can just copy the 90 days and paste here, but that's okay. Then I can retype this. So minimum days, 3 months, let's say 90. And the variable and the maximum days 180. So once you declare these two variables, return, then use a calculate expression to start to first do a distinct count of customer keys in the sales table by the condition where the sales the sales date of first purchase, right? Sorry, the sales, that will be days since the difference days since first purchase. The calculate column is above 90 days. Let's just not use equal because we're already using up to 90 days in the 90 days measure. So this one should be above 90 days, I think. We will see. And let's just declare the second one. Again, this comma means the double ampersand, which you use in a filter context, which means and. So it's a true and true logic. Dates as first purchase, and then put below or equal to 180. And that will be the second variable. Why did I put the 90 actually? I probably got confused, sorry. It will be 3 months. Days, next one, days, 3 months. Alright, and then close the parentheses, and then maybe just add the 0, and I'll just explain to you why you need to do that. And actually, it's the best time to explain it. So if you don't add the 0 for any record that you don't have a value, you'll just get blank like these ones, like the distinct values, like they have it here, right? So apparently they probably did not use it in this case. So anytime that there's no output, then Power BI automatically just leave those as blank. But if you there's so many ways that you can add the 0. One of the ways to add the 0 at the end of the calculation, and what it will do is it will just add whatever output you have, the value with 0. So if you have 34 and just add a 0 to it, it's still going to be 34. But if you have a blank value and you add 0 to it, then you get a 0, right? So that's the idea. We don't want to have blank values. Instead, we want to have zeros. And there's several ways you can do this. You can also do if it's blank, then 0. Otherwise, at least there's at least 3 ways I know how to add zeros for like null rows or blank values. All right, click on commit, and so our return with the next 3 months measure is now created, and I don't see any underline, I don't see any error, any typos, so we flagged, so we're good to go. All right, let's go to return within 90 days sales, and let's just drag and drop this to the end of the columns here. There we go. 2. So we have 15 people who return within 90 days. We have 2 people who return within the next 3 months. All right, I forgot to do this distinct count. Where's the distinct count? Where is it? So it should be the customer list. Yep. So you can see 0. That should do it. Now all of this is now 0. Another way you can do this is, let me see, I used to use it. I think it's if it's blank. If this is blank, let's see if this will work or not. No, let's use if it's blank, and then yep. If this function is blank, the output of this function is a distinct count of customers' keys. Blank, then put a 0. If it's not blank, then just use the function, and then open, and then one more parenthesis to be able to count for the if. Let's see, and boom, it worked. It worked. So either adding the 0 or using this, and there's also one more method. All of them will work. And there you go. The 2 is here. Right, so, let's not forget that we have a key measures to follow. So this one is done. This one is done. The customers return within 90 days. This is done. And this is customer return within the next 80 days. This is done too. So the only things left is percentages. 90 days and percentage for 3 months. All right, so let's go back here and create these 2 measures of percentages. So it should be easy. We're going to just create new measures, and let's say that will be percentage return within 90 days. This one will be first. And by the way, the naming convention is something that you can just decide for your own, depending on whatever naming convention your company uses. It's selective, based on what fits your needs. So there's a lot of different standards like KMOKs, capital, first letter capital that you can use. So sometimes I just use non-conventional ways. It all depends on how heavy the project is and what your company has implemented in terms of naming conventions. So just use that. All right, and the return within 90 days, I'm just going to use the very basic arithmetic of divide, and then the first, our numerator, our numerator will be the one that says, that will be the first measure, which is the return within 90 days. Oh my goodness, okay. Return within 90 days. And so once we put that and we put a comma, then we'll put our denominator, which is going to be the names, the distinct count of customers, which is this one, customers list. And there you go. We can also add the 0 in here, just to get 0% for any instances where we have 0%. There you go. So let's just drag and drop this newly created measure after the 90 days. And there you go. We created it. One thing we need to do is change the format. So return within 90 days percentage. We need to change that to a percentage. You can also change it in the measure itself by adding format function to it, but it's easy to do it this way. So there you go. We can also decrease the decimals if you want. We'll just keep it at 2 at this point, I guess. There you go. Good, beautiful. Let's create our last measure, which is the. All right, so this is done too. The percentage is done. Let's put it down here. And we're going to create the percentage for following 3 months. Let's create a new measure here, and this time we just call it return within, or return next 3 months. Just say pretty much the same thing, divide. And then this time we're going to use returned next 3 months measure here. And then the other one, the decimal for the numerator, and our denominator will be the same thing, which is this one customers. It's from the customers table. And close the parentheses, and then 0 to be able to count for the blank values. Forgot to add the percentage because I was saying there's already a label, a measure label with the return next 3 months. So let's click on commit. And our percentage return within the next 3 months is also created here. All right, so we can just drag and drop it after the return within the next 3 months here. And it is here. Only thing we need to do is go to the format and change this to percentage as well. And there you go. Okay, so what is going on with this percentage? Why didn't we get it? Oh, I was worried, like, what happened? Why didn't we get the zeros? There you go. So that's probably why. I saw some blank values. There you go. Okay, so apparently, of all the first-time purchasers, based on the simulated data that I put together, of all the purchasers that made first-time purchases, 48.39% of them returned within 90 days, and only 6.45% of them returned within the next 3 months. So these are aggregates at the end. And then we also have them broken by each month. Beautiful. I think this is very good. It's working out fine. All I have to do now is just go and replace the dummy data I created here with the actual data. In fact, let me just delete this. This was just something I added there for to show how you can automate or optimize date parsing from the customer's data. Let's refresh this really quickly. Okay, so what did I do? Then I just delete this. Okay, this looks good. Okay, this looks good. The only thing I need to do is change the names of each of these columns, and then also sort these months and years going from lowest toward highest. Let's just start with the month and year. What did they call it? Month. Okay, in fact, I can get it from my Microsoft Word. And just start labeling them just what they ask for. This one should be customers. And then customers who returned within 90 days. And then this will be percentage. Percentage. Oh, just get this one. And lastly, beautiful, beautiful, beautiful. I mean, this should do it. I don't see anything else that needs to be added. Based on the instruction they provided me, this should answer the question. All right, the only problem I see, and this is something that Power BI needs some workaround, it's not as easy, is the date filtering. So if I filtered, I want to filter, sorry, sort. I want to sort the dates going from the lowest date toward the highest date. But if I sort them, as you can see, I am doing right now, I'm not really getting a the date logic sort applied here. I'm just getting text logic sort, and that's because this bad boy here, month and year, is actually a text, right? So I want to keep it 3-digit month and then complete digits for the three characters for the month and all digits for the year, right? So, but it's coming as text, so it's a special format. So if you do a special format, then you'll have to accept the fact that it'll have to be a text. So when you sort on a text, you're not going to get the same treatment as you would do if you sort on a date. For example, if I sort on a date here, you will see that everything is sorted based on the date logic, not based on what comes 4, what comes 3, not like that. So, however, when it comes to this month, bad boy, month, year, any sorting that will happen will be based on the alphabet. S is coming first, maybe next O is coming second, right? So, and that's not what I need. So, you will face circumstances where you will have to use a different column to sort a column that's not sortable. And what I mean by that is, for example, here month and year, you want to sort by month and year. And if you want to use the date to sort it by, you will not be able to do it because it creates what it calls a circular dependency. And we can try it. So sort by date. There you go. It says, can sort month and year. There can be more than one value in date. So this one is saying we can't have more than value associated with each one of them. So, for example, September has multiple September values, so it won't work. So, what we need to do is we need to create a numerical date value, so that we can use to perform a sort on. So what I mean by that is in our date table, we're going to create a calculated column. Maybe we can call it, in fact, I don't have to create it as a new column. I can actually create it within this DAX where we created the table, and just simply add a, excuse me, just simply add a comma here, and then start with a new calculated column. Let's just call this month year for sorting, right? And it's going to be a little bit tricky because we're going to use the year, right? The first chunk of numbers will be the year, and that's going to come from date. And then we want to multiply that by 100. It's a technique that you can use when you want to quantify or make a number, the alphanumeric data type into a number data type. So, and then add the month, which is the month, which is the other chunk index of the date, and you can use the date to add it there. So let's see if this will work. Add two parentheses to count for. There's already a parenthesis up and down here. So let's click on checkbox here. There you go. So now we created exclusively a whole number data type that corresponds with each of these months. So for example, September 2024 is 2024-09 now. So we will fall into a circular dependence. We also won't fall into multiple values that will prevent us from sorting. So now we can sort by month and year. And before I do sorting, you can see that I try all sorts of sorting, and still, our years are all over the place. The months are all over the place. It's not a appropriate sorting. So let's go ahead and sort the month and year, and select the month year for sorting as the value of the sorting. So, and there you go. It worked. Let's go check it out. And bam. Going from the lowest all the way to the highest. Or we can go from descendingly from the highest or the lowest. So anytime we sort on this column, which is month when the first purchase was made, which is a text column, which is character column, the sorting logic in the background is fed from the numerical month years column we just created. Okay, I think this is ready to go. We can also let me just check one more time. I added, as I said, two additional columns, which is this one and this one. Maybe we can check a couple of these just to be sure I'm not making a mistake, right? Let's say in the month of June 2021, we had 3 customers. 2 of them returned within 90 days, and none of them returned within the next 3 months, right? So let's look at those 2. Let's just go to June 2021. Let's go to customers, and let's go to first month purchase. Let's just find June 2021, which is year. There you go. We have 3 customers that had first purchase in this month, and so 2 of these customers actually returned, which is which one are they? So let's go to sales. Now we can't check by date there because it's within 90 days. So let's just go by the customer key. So 1004. First purchase was June 19. So 1004. 1004, which is this one, and his first purchase was uh, okay, his first purchase was June 19. Okay, June 19. Okay, so June 19, 1004. So June, July, August, September. So this order date for 1004 is way out of June. It's way out of the 90 days. In fact, it's even way out of this. It's the 6 months. So it's June 19, December 19. So this one is probably one of those that didn't return. So what about the other two? 1006 and June 12, 2021. 1006. So keep that number in mind. 1006. There you go. July 12, 2021. So July 12th versus June 12th. So he did return within 30 days. That's good. If we go to 106, 30 days. There you go. And the last one is 1013, customer key 1013, John. And his first purchase was in June 18. June 18. So 1013, and his first purchase June 18, and then he came back in August 18. So 1 month later, 31 days later. Okay, the logic works, the analytics, the analysis work, the measures work. Everything looks great. If you want, we can also check one record from the 3 months. So let's just check. Maybe this one, March 2017. March 2017. In fact, you can also, since the model is established, you can also add the customer keys if you want, right? So if you click on customer key, you can actually add the customer key. And there you go, the customer keys are here. So the one that returned and for the 3 months is here, February 2016, and it's the ID is 120, 1020. In fact, let's just put the first purchase date here as well. But I'm going to remove it. I'm not going to keep it there for the company. Okay, so what month was it? So it'll take a couple seconds for it to populate. And there you go, February 20, 2016, 1020. Okay, 1020, February 20, 2016. All right, so let's go to sales, 1020. And there you go, June 20, 2016. So February 20 till June 20, that's March, April, May, June. So it is within the 30 days after the 90 days completion. So it is within that 90 to 180 span, which is 121. So perfect. Everything is working perfectly. Let me just remove these extra fields back from the table so it's doesn't have any extra columns in here. All right, so this table meets the requirement of the report that they wanted me to replicate. It has additional metrics to showcase for them, but I guess I can also add a few visualizations just to effectively showcase my skills for them, not only what's needed, because I guess with this table I meet all of the required specifications that were outlined in the instructions. But if I were to create some visualizations based off of what we have available here, maybe we can use a line chart, right? Something about the visualizations in Power BI is that you can use those that are available for free, and then you can also import visualizations that are created by other, well, I'm not synced yet with Power BI, but you can also use other visualizations, graphics that were developed by others, which you may need to either purchase or can also download for free if it's not commercial. So let's just make use of what's available, and line chart is one of them. So we can, for the line chart, as you can see here, there's an x-axis, and then there's a y-axis, and then there's secondary y-axis, and then legend, a small multiple. So The basic fillers need to be, for example, for the x-axis, it could be month and year. It could come from a date table. The modeling is in the background, and it's always working, so don't worry about that. So as you drag and drop, or as you populate, as you fill in your these boxes with the measures and fields, the visualizations will still populate the visuals based on the model that's working in the background. So don't worry about that. So a month and year is added to X. Now our Y could be a measure. In that case, maybe we could put the customers list, right? There you go. That is the customers, distinct customers, or the customers who made first purchase by each month and year. Another good thing about what you see here is that our dates, month and year values are automatically sorted from ascendingly, in this case, from lowest to the highest. That's because the sorting that we established in the background earlier, right? It just like the table model, it's always working. So you don't have to do anything extra. You can also, I guess, also change it from here if you want to change it, do however you want to do it. But this is good. So this is going to be a very basic visualization here, but because we don't have a lot of data points, and this is just a dummy data, just very minimal data points. Line chart does not really look so good here, but if I use the actual simulated data that they provide me, this line chart will probably look much better. We can also add, do a column bar, cluster column chart, right? This will also help us. Maybe we can use the month and year for the x-axis, and maybe for the y we can do 90 days measure. There you go. And again, because we don't have a lot of data points, we're really not getting a a beautiful one. There's a lot of space in between. Yeah. If we were to break it down, let's say by categories, let's say if you want to break it down by the categories of gender, just put it in the x-axis before the date, and there you go. You will get a male versus female. That's good. Actually, we can remove the month and year since we don't have data points by month and year. Maybe just do it, use the gender as our categorical X for the x-axis. And there you go. And maybe we can just add an occupation. I don't know what English occupation means. See. There you go. So broken down by male and female, and broken down by the categories underneath each one of those. In fact, let's just put it under male and marital status. So there you go. So now we have a female married and single, and a male married and single. So it looks like our female singles had the highest number of return within 90 days, which is 6, while our single males is 0. Our second lowest is the female marrieds. But again, it's just my own dummy data that I created, which is not really suitable for any visualization. But yeah, we can also create metrics. Let's say if you want to, let's say get the month year for the rows, and then return within 90 days, within 3 months, both of them as values. And then you can use the gender as your column, which allows you to break them down. So this is another beautiful visualization, tabulation that's suitable for this analysis, where you're looking at return by 2 ways. It's called a cross tabulation, or 2-way table, by month, year, and then by gender. So for example, in February 2016, 0 returns for female for 90 days, 1 for 3 months. However, for the male, it's 0. So we have data. This will look much better. So the metrics is a good. It's more like it's like adding a layer on the top of a table tabulation. We're looking at two-way cross tabulation. As you may know already, that Power BI Desktop allows the integration of Python scripting in order to create various visualizations using Python graphic libraries and modules. So what I did was, in order to keep the video concise, although I know I'm past the time, I went ahead and quickly wrote a script to create a heat map in order to show a more comprehensive visualization for this work. I don't know if I will submit this or not, but I thought it would be nice to have this. The heat map is really not available to use from any of the visualizations that are ready to use from Power BI. So for anything advanced, for any visual advanced graphics, you may need to integrate Python or leverages in order to produce them, which is what I've done here. I use the Python script editor within Power BI to create that. So a heat map is a data visualization technique that uses color ingredients to represent the intensity or frequency of values across a matrix or a spatial area. As you can see, I've used several libraries here and modules. The first one I use is the matplotlib, which has the pyplot, which can be used to display or save the heat map. For example, using the plot.show, we can render the heat map on the screen. I use the Seaborn, which is a main library used to create the heat map. For example, SNS.heatmap, that simplifies creating attractive and informative heat maps from numerical data. We already know pandas, so these are used for general data transformation or exploitation purposes, like loading, manipulating, organizing data in structured format like data frame. Sometimes it can be passed directly to SNS heatmap. And lastly, use the customized matplotlib ticker to customize axis tick formatting to display the percentage, as you can see here, in a format that's readable and also concise. So I'm not going to spend too much time explaining all of these, but I'm going to share this with the video in case you want to replicate it. And once again, the heat map is a very strong visualization. It produced a gradient going from pretty much light color representing low value to stronger color representing high value. And this heat map specifically, the color scale tells us how high or low the values are. Typically, the lighter colors indicate lower values, and the darker colors or warmer colors show higher values. For example, in here, the darker blue shows a high concentration or frequency of returns, while the light blue or say yellow represent a low one. So I'm also using a color map from the Seaborn library. That's a yellow, green, blue. So we can change that to a different color map. For example, we can change it to magma. I've used this one before. Let's see how it turned out to be in this particular heat map. Given the fact that we don't have too many value data points, going from dark to yellow, so it's going to be a good color mapping schema. Or maybe we can try plasma. Let's see. It's going to take a couple of seconds. you're using within Power BI Desktop, it's process. There you go. It's not a bad one either, but I think the yellow, green, blue, it maybe the most suitable color mapping here. So blue. But no, sorry, I have to put the to make sure that you spell it with first letter capital for each color. All right, so I'm not sure if I will be providing all of these visualizations to that potential employer or not. I'm not. I'll probably, after the end of the video, I'm probably going to work on doing some formatting for this, although I know that this could be improved. I don't think I'll be providing the metrics, so I'll probably delete this one, although it's a good way to explain that breakdown between male and females, the marital status. That was just for the purpose of illustration to you guys. I'll probably just send the, also get rid of the line chart. I'll probably just send the heat map and this table, this is the only thing I asked for. So I don't want to provide too many visualizations that it can hurt my performance. They would be like, that's not what we asked you for. But this should be the end result. I'll also get rid of the total so we don't see the aggregates here at the end. And most importantly, I'll replace the data with the actual data so that they get to so that they can see the expected metrics here. And they also asked me, if you remember, they asked me for 1 to 2 pages report demo highlighting my capability in terms of both data analysis, report design. So I went ahead. Again, I didn't want to spend too much time writing this while you guys are watching me do it. So I wrote a couple pages of information. And the objective, I said, this report provides descriptive analysis regarding customer purchasing behavior to determine the effectiveness of customer retention over time, particularly the return patterns within 90 and 180 days. The key metrics displayed is something that we talked about at the beginning of the video. The tools that are used as Power BI Desktop is a primary tool for data modeling, transformation, and visualization. Power Query, mLanguage. So mLanguage is any scripting that you do within the Power Query. mLanguage in itself is a different syntax than DAX. So I made a mention here that I use that for the ETL, for cleaning, merging, and enriching the data before loading them into the model. And last, I used the DAXs, which is the analyzed expressions, initially for logic validation and basic calculations. And the methodology is that I made it clear that there was no data dictionary, so I wasn't sure which one of the customer keys I was supposed to use. So I used the customer key. So the decision was made to ensure data integrity and maintain a clean, reliable model. Introducing both keys without a clear understanding of their distinct roles, risk introducing ambiguity or redundancy in the model. So I said I wanted to use both as a composite key, but I opted to use only the customer key for established relation between the customer and the sales table. So I didn't want to introduce ambiguity or redundancy in the model. So I said in the future scope or business requirement indicating need to reconcile and incorporate both identifiers accurately, I'll revisit this aspect and implement a solution that can dynamically resolve customer identity across both key types, possibly through surrogate keys or advanced merging logic. So that was my custom approach. And then data transformation with Power Query. We removed the unnecessary columns for performance and clarity, and then we clean up and optimize. So we didn't do a lot actually, just the removal of some of the columns and also moving the first row as the header. So I'll just still put it in there because that's the best practice to use the Power Query for data transformation. Maybe when I
implement the actual data, I may have to do some optimization and cleaning. So I'll just keep it in there just in case when I apply their data, if I will need to do any cleanup. All right, data modeling, establish a clean star schema using the customer table to relate accurately with the sales table. Insert a one-to-many relationship between customer and sales table using the new customer keys in both tables. I should say the customer keys, no new customer keys. The sales table establishes the central fact table containing transaction level data. Dimension tables, including customer table, product table, and a date table, were connected to the fact table using an appropriate one-to-many relationship, something I may have to revisit. Relationships were configured using the unique keys to ensure clean and meaningful joins between the tables. A custom calendar table, which is the date table, created directly in Power BI, not Power Query. This table included key fields such as date, year, month, year, and other derived time attributes. It was marked as the official date. Maybe I should just not mention this. Just keep this brief for right now. DAX calculation created several calculated fields and measures to measure for sales return within 90 and 180 days. Tested and validated the return flag logic using a set of unknown or dummy data cases. So I would say that I can use what we did in this tutorial as the validation of the solution. Ensure that the DAX expressions performed correctly across various edge cases and customer segments. Output. So what is my output? Summary table to directly address the business question, which is that table we talked about, which displays the customer keys, first purchase date, and return flags within 90 days or 180 days. And the number of customers returning over time by month or week, segmented by return window, 90 days versus 180 days. So this is something I will probably not do then. I was thinking about just recreating recoding the month and year, and then pretty much creating a weekly segmentation of customers' first purchase. But maybe it's not a good idea for right now. Just leave it there. Python heat map advanced inside. Use Python scripting C1 and Matplotlib within Power BI to create a heat map visualization. Display aggregated purchase values by date segments. All right, so those are all the approaches I use, and then just some enhancements for the future. I said, while the current analysis provides a basic descriptive foundation, highlighting fluctuations in customer return behavior, it can be significantly enhanced using advanced data modeling techniques. So I want to make sure that they understand this is a basic descriptive foundation, which is what I was asked to do. So this could be enhanced into advanced levels of analysis. By leveraging predictive analytics, we can forecast future customer behavior and understand key drivers of retention. For instance, a survival analysis model, I explained it, Kaplan, Meier, and Cox regression. I don't know if I should keep it in there, but could estimate the probability of customer retention over time, identifying the likelihood of a customer returning at various intervals. Additionally, the logistic regression or classification models like decision trees, random forest, or gradient boosting can be trained to predict which new customers are more likely to return within 90 days based on early signals such as product type, time of year, or order characteristics. So there are some variables in their data that I can use for training classification models that can help us predict some of the core behaviors. That shows, with this, I'm trying to show to them that, the primary goal is to produce this very basic descriptive churn, but it could be investigated at higher predictive levels to produce a good effective model. So additionally, clustering methods, clustering methods such as K-means or DV-scan can be applied to segment customers into behavior groups based on purchasing frequency, return pattern, and spend level. That's another level of analysis. It's not really predictive, but it's more like clustering. The segmentation or clustering, I said this clustering technique.
would enable the business to tailor retention strategies, such as targeted email campaigns or loyalty incentive to different customer archetypes. All right, so the clustering could help that achieve that. Combining time series forecasting with cohort-based lifetime incentives to different customer archetypes. Lifetime value LTVs modeling will also allow the organization to estimate long-term profitability of customer groups acquired in different periods. Finally, integrating transactional. You know what? Maybe I should not say this because I already mentioned. I already talked about survive analysis. That's a more effective analysis in this case. Finally, integrating transaction engagement data into a machine learning pipeline can yield an automated early warning system for churn, allowing proactive outreach before this engagement occurs. And lastly, I would like to point out to them that by evolving from retrospective reporting into predictive and prescriptive analytics, the business can not only understand what happened, but also anticipate what will happen. And more importantly, how to act on it to drive growth and loyalty. This should be a comprehensive description of what I've done and what can be done moving forward. And I will work on adding maybe some titles to this. You can do it from here, from format visuals, titles. You can turn on the title and add a title. These are like more like drop down stuff that you can easily use. Just has to do with how you want to format them. So everything else moving forward is pretty much intuitive, something that you can do yourself as well. So I guess this is it. So I think I can say that this report is now finalized. Thank you.
All right, we are back, and that brings us to the end of this project. I really hope that this video was educational and that you were able to pick up some valuable skills, whether it was importing and shaping the data with Power Query, or writing DAX expressions for calculated fields, columns, or measures, or even developing impactful visualizations. Please try to experiment with your own data sets and try building something similar to what I just did now. And if you have any questions, or if you'd like me to create more deep dives like the one I just had now, please let me know in the comment. Again, thank you so much for supporting my channel. Until next time, keep learning and take care.